So I talked about this already. It's different. There is a difference between your first and second differentials being equal to 0. So what you need to do when you're talking about concave and convex, you need to draw a sketch, differentiate, find stationary points, find your second differential, identify the nature of those stationary points, do a final sketch. So if your first differential is 0, then there's a stationary point, which means the gradient stops increasing or decreasing. It can be a maximum, minimum, or inflection point. If also the second differential is 0, it's an inflection point. Okay, so here we go. Here's an example. Sketch and identify the critical points. I'll pause and let you have a go at it. You can use the checklist if you want. Okay, going through the answer now. So that's what your graph should look like. Here's the working. So you've got the function, you factorize, you've got one root. You find your first differential, pop that equal to 0. You've got one value where that equals 0, so you've got a stationary point at x equals 1. And you find your second differential when x equals 1, that also equals 0. So we need to think about whether it's an inflection. So we've also got to check what's happening just before the point x equals 1, so x equals 0, and just after x equals 1, so what's the value of the second gradient. So this was like a rough sketch. This is what it actually looks like. You've got that one root, you've got one stationary point, and that stationary point is a point of inflection, and we have to check that it it does change sign either side of that stationary point. So if all you've worked out is that the second differential is 0, there could be a point of inflection, and you have to do that checking of the sign change. Okay, you've got to check the sign of the differential changes, because it might not. It could just be a very flat maximum or minimum. So you can have anyway, basically that's the other option, or an undulation point. I'm not even sure what that is. You definitely don't need to know that for A-level maths. So you can have a second differential equal to 0 without the first differential being to 0. That's a non-stationary point of inflection. So let's have a look at this. So critical points, non-stationary inflection points for this curve. So have a go at it first, and then we'll have a little look at the answer. There's your checklist if you want that. Okay. So that's what we're looking at here. So you take your graph, you factorize as much as you can, and you've got your repeated root and your other two roots there. You've got y by dx is this, pop that equal to 0 and find where your maximums and minimums are. You find your second differential to confirm. So for example, this one, x equals 0, you've got d squared y by dx squared is a maximum, and equally at these 2 points you've got d squared y plus dx squared is a minimum. Now what about your inflection points? So when you've got d squared y by dx squared equals 0, so remember, you find the second derivative to check whether something's a maximum or minimum. You put the value of x in for the point that you're checking, so the 1 and the plus or minus 2. Okay, there and there. Your inflection point is when the second derivative equals 0, and we get plus or minus 2 over root 3, which is these points marked here. Those are inflection points, and they're non-stationary inflection points. So have a little look through that working, and yes, there should be a little bit more working. You should check your second differential changes sign, just like we did in the previous example. Okay? So, point of inflection is when a curve changes from concave to convex, and you can have that change without a point of inflection. And here's a very straightforward example. It's when basically 0 is not in the domain. So there is no point of inflection because where it would be is just, that is not defined because of the nature of the function. Okay, right, so this is what you're doing. You find dy by dx. If it equals 0, that means you've got stationary points, maximums, minimums, points of inflections. And then you find the second derivative. If that equals 0, you might have an inflection point, and you should check either side. You're looking for a sign change one side of the inflection points. If there's a sign change, you've got a stationary point of inflection. If you've got no sign change, you've just got a very flat maximum or minimum. Okay, if d squared y by dx squared does not equal 0, it's either greater than or less than 0. Greater than 0 is the minimum, less than 0 is the maximum, like last year. So if your second derivative does not equal 0, you don't have stationary points. However, you can calculate d squared y by dx squared, and if that equals 0, you might have an inflection point. You're looking for that sign change. If you get a sign change, you've got a non-stationary point of inflection. If you don't get a sign change, there's nothing exciting going on. If your first derivative and second derivative don't equal 0, they're not critical points. Okay, here's your application. I'd like you to pause and have a go at this question, please. Right, so here you go. There's some fairly straightforward working, I think, and the explanations are quite clear. So you find the first derivative, you find your second derivative, you think about when it takes a negative value and when it takes a positive value for concave and convex. So that's for part A. For part B, find the coordinates of the point of inflection. That's when your second derivative equals 0. Get your x value, get your y value, that's your point of inflection. Now, because you know the second derivative changes sign either side of this point, because at 0 it's concave and then it's convex, so you know that you've got a different sign. Okay, right. Nice little summary that I want you to fill in. So you've got convex, looks like that, increasing, decreasing stationary point. Concave is kind of the opposite, and points of inflection look like that. So I'd like you to fill in that table in your notes, please. Here's an exam style question. Find the points of inflection and hence state the intervals. And I think this is fairly straightforward. You find the first derivative, you find the second derivative, you pop the second derivative equal to 0 and get those points of inflection. Remember their coordinates, so make sure that you find the y value as well. And therefore the intervals, you look at the definition of concave, make sure you write that down in your working, and you write the range of values over which of x values on which f of x is concave and f of x is convex. You can write intervals like this, but I think writing inequalities is safer, to be honest. So I hope that was okay, and I hope that combined with the videos I made you watch yesterday is enough. These are the questions that I would like you to practice on this topic. Thank you.